Welcome, elementary educators. In this screencast, we take a look at some basic geometric notions. In particular, we look at the notion of an angle and what it is and how we use it, etc., how we use angles, and so on and so forth. Let's be clear about what we mean by an angle. An angle is the union of two non-opposite rays that share an endpoint. This thing is called an endpoint for each ray. It's the endpoint of this ray, it's the endpoint of this ray. And so with respect to the angle, we call this the vertex of the angle. So in this particular case, we have point A here, and we have a point B over here, and a point C over here. And so we would call this angle BAC, or we might write angle BAC, but we would write either the word angle or this symbol that looks like an L that got pushed on one side just a bit. That's an angle BAC. Um, some people would call it angle CAB. That's fine as long as the vertex is in the middle, the vertex is in the middle. If you're going to call it by one letter, you call it by its vertex, and you would only call it by one letter if it was obvious that there was no other angle that also had a vertex at A. Now, in truth, the angle itself is just those black lines. But usually we care about the space inside the angle, and that space is called the interior of the angle. That's the thing that we often measure. We're interested in how big that area is relative to all the way around in a circle. A small bit of vocabulary: if you have an angle like this, maybe vertex at A, and another angle like this, also vertex at A, so maybe that's point B, and that's point C, and that's point D, we would say that angle BAC and angle CAD are adjacent. And that just means that they share a ray in common. That ray is this ray, ray AC. That's a ray that they have in common. Now, everybody is familiar with the idea of a protractor. Everybody has played with one of these at some point, where you have this point right here. It's where you put the vertex of your angle, and then oh, really? Let's undo that. That was just silly. So then you measure out how big the angle is. Now, of course, there are two numbers here. There's a 120 and a 60. How do you know which one to use? Well, angles that are less than a right angle, we use the smaller number, and angles that are bigger than a right angle, we use the big number. So if this is one ray in the angle and this is the other, then that's bigger than a right angle. We call that an obtuse angle, and we would say that that angle measure is 120 degrees. Halfway around the circle is 180. It's as far as you can go. You really can't even go there, and that's fine. Your textbook refers to two things that I don't pay attention to. One is a straight angle, and the other is a reflex angle. Acute angles are less than 90 degrees. Right angles are 90 degrees, 90 degrees. And then angles that are greater than 90 degrees are called obtuse angles. So for clarity's sake, angles that have measures less than 90 degrees, those are called acute. Angles that measure 90 degrees, right, usually symbolized like that, those are called right angles. Angles that measure more than 90 degrees, those are called obtuse angles. Okay, your textbook refers to something called a straight angle. Lots of people believe that those exist. I, in my geometry classes, do not. I don't do those. An angle is a union of two non-opposite rays. These are opposite rays. Your textbook also refers to something called a reflex angle, an angle that's greater than 180 degrees. Your textbook refers to such a thing as a reflex angle. I don't worry about that. Those don't bother me. I don't pay attention to them. I don't really talk about them because geometers don't talk about them, and that's okay. One other thing in this screencast, we should talk about this shape because the whole 180 degrees, 360 degrees is about this. So if you happen to have an angle that is centered at the center of this circle, maybe O is the center of this circle, and you have this angle right here, and this angle measures, I don't know, 70 degrees. That seems fair because 90 would be straight up, and this is almost straight up. Well, it turns out that the arc measure here is also 70 degrees, and that's kind of the idea with this um, reason. When we go all the way around a circle, that's 360 degrees. When we go all the way around this angle, just starting here and going around, that's 360 degrees. There's a linear relationship between central angles and their arcs. So central angles have the same measure as their arcs. And this almost makes sense. Um, a thought that we should probably have, this segment is called a radius of the circle. If we go all the way across from one end to the other, a segment AB, that segment is a diameter. It's a diameter, nothing fancy there. Incidentally, how big is this angle? Well, that's an excellent question and is easy to answer, actually. If this is 70 degrees and halfway around the circle is 180 degrees, then this is 110 degrees. And then we have a triangle where two of the sides are congruent, and so two of the angles are congruent, and both of those have to measure 35 degrees. So just remembering some things that we used to know about circles. What's a radius? What's a diameter? How do angles and arcs play together? There's things we should be aware of. Okay, it's a lot to take in with angles. Hope that that's okay. We've got to talk about another big word in our next screencast. We've got to talk about what it means to be perpendicular. We'll see you there.